To become a competent systems programmer, these subjects are quintessential to understand. You do not need to master each of these, but you must understand them more deeply than software engineers from other domains. Later on, you can pick your specialization from these subjects or their related ones. First, C programming, where you learn to get a hold on high-level aspects of programming in C, which is a popular system-level programming language. It was used in writing the Linux kernel as well as your original Doom. Second, Born-Again Shell, to get a grip on how to use your default Linux shell properly and write scripts, given that most of our course is related to writing programs on Linux. Third, Linux Dev Tools, where we will learn how to use some of the very essential development tools in Linux, which aid us in writing, debugging, and maintaining our software. Fourth, x86 assembly, which is focused on learning, understanding, and writing programs in assembly, which are later converted to binary instructions for the processor. Fifth, digital electronics, where we will learn about how the underlying hardware works, along with a hardware descriptor language used to define circuit logic. Sixth, data structures. Software's efficiency depends a lot on it, as importantly as selecting the right tool. It's about how our data is involved in code, arranged, written, and accessed. Seventh, system calls, where we will learn how to write programs that pass our requests directly to the kernel instead of being filtered or safeguarded from user space services. Eighth, executable and linking format, which is the binary format used particularly in Linux-based operating systems. We might also explore portable executable, that is a Windows binary format, and Mako for Mac. Ninth, operating system. As the name suggests, it's all about operating systems, be it about its internal design, common features, software-hardware interface, and so on. But this particular series will be more theoretical. 10th, device drivers, which is about writing programs that bridge our hardware devices to be recognized and operated by our operating system. It's one of the most challenging subjects in this list. 11th, bare metal programming, which touches on embedded aspects of systems programming, particularly for x86 processors, including those from Intel or AMD. 12th, computer network, where we will explore networking, its related hardware, and how communication between multiple systems takes place at the level of bits and binaries. 13th, compiler design is a brilliant subject to explore the rules applied when creating compilers. We will also make our own small code processing programs to demonstrate those concepts. 14th, automata theory, which is more descriptive than compiler design when it comes to understanding the mathematical core in language models, their use cases, and evolution over time. There will definitely be more related subjects that will be added to the list, covering other processor architectures, but these are the compulsory subjects to study before going further. It might look like a lot, but remember that it's extremely rewarding.